Welcome to hydrogen. Hydrogen is an important element in the energy transition in general and for the energy transition in the process industry in particular. In this video, we will discuss where to use hydrogen and how to make it. The periodic table of elements is used by chemists and other scientists to present in an organized way all different types of atoms that exist. When looking at the periodic table, hydrogen is the first element. It's in the upper left and with a red box around it. It is the simplest and lightest atom. Another important element is carbon, number 6, also with a red box. And together they are the building blocks of many important chemicals. Think of fuels such as gasoline, diesel and kerosene, and plastics such as polyethylene and polypropylene. If you also add some oxygen and/or nitrogen, you can make even more products. For example, pharmaceuticals and fertilizers. When talking about hydrogen in the energy context, often molecular hydrogen is meant. A hydrogen molecule consists of two hydrogen atoms that are bound together. In the past years, there has been a lot of attention for hydrogen. It has sometimes been presented as the silver bullet for the energy transition. But the reality is that there is an important role for hydrogen, but that there are also several applications where other means than hydrogen are a better choice. How smart it actually is to use hydrogen for a given application is nicely illustrated by the hydrogen ladder that was introduced by Michael Liebreich. In the upper section of this overview, we see applications where there is no alternative for hydrogen. And these are in fact often applications where the primary role of hydrogen is not providing energy, but providing hydrogen atoms that are required in chemical reactions, so as a building block for materials I mentioned before, for example fuels and plastics. This overview makes clear that one should first provide the process energy with hydrogen before moving to other applications. It also shows that there are many applications to the bottom of the overview where the deployment of hydrogen is not very useful. For example, batteries have become much better and cheaper in recent years, and they are now often the better option for transportation over not too long distances. Please note that not everybody will exactly agree with the precise positioning of every application in this overview, but I think it does give a decent indication. The hydrogen that is needed for the relevant applications can be produced in many different ways, and hydrogen is typically labeled with different colors to show this. And just to be clear, this is a paper exercise. In reality, hydrogen is completely colorless. Green hydrogen on top of the table is produced via electrolysis with renewable energy, and pink hydrogen just below it via electrolysis with nuclear energy. And these two types of hydrogen have the lowest carbon footprint. Now, unfortunately, not everybody is using exactly the same color scheme. Some people mean with yellow hydrogen, the hydrogen produced with solar energy, but we use it here to label hydrogen for mixed origin grid energy. Another important one is blue hydrogen, one step further down, and that's hydrogen produced using fossil fuels, but with carbon capture, so that the CO2 is either stored or utilized. Finally, we have a number of hydrogen types produced from fossil fuels: turquoise, grey, brown and black, with various greenhouse gas emissions. Now, to give you some idea of the main chemistry behind the processes to make hydrogen, I give you here the simplified reaction equations. The upper one, electrolysis, is where we use electricity to split water in hydrogen and oxygen. The produced oxygen is typically a less useful product. The process industry does not need it in large amounts. The second process, reforming, is currently the most widely used route to make hydrogen, and especially in Europe. Here natural gas is used as the feedstock. Although prices will vary over time, let me give you an indication to compare the first and the second approach. Hydrogen from reforming costs around €2 per kilogram, while green hydrogen is currently about €10 per kilogram. And this shows that it will be currently hard to make this transition. Pyrolysis, the third one, can refer to a broad range of reactions with different feedstocks and different products. Here we focus on hydrogen produced from natural gas, methane. The nice feature of pyrolysis is that you can get the carbon as solid carbon, so in principle you do not emit any CO2. But it's important then to find a good application for the carbon to make the process economically attractive. The final process is gasification, which can be seen as incomplete combustion. Apart from hydrogen, you also make CO in this case. The mixture of hydrogen and CO is called syngas, and it is useful in many chemical processes. More about this in the next video. To summarize this video, hydrogen is not necessarily useful in every sector, but it is crucial for the energy transition of the process industry. The hydrogen ladder is a nice way to illustrate in which applications it is very useful and for which there are better alternatives. And there are various technologies to produce hydrogen. They have different levels of greenhouse gas emissions. Thank you very much for your attention.